Test, test. Okay, I do not see anyone connected from online. Maybe they will join later. So let's say hello to the camera, just in case someone will join us. Yeah, thank you for your continuous effort of not dropping this class and tolerating me. So this is the physical chemistry course. Original announced goals were to interpret and predict outcomes of the instrumental measurements and predict properties of materials. And as you see, we are quite far from this goal, but we are moving slowly but surely. The wavy nature of electron needs either heavy math or computerization, and we are creating skills to solve problems that we would find difficult to solve by pen and paper. So therefore, we bring this additional component, which I think you appreciate much more than derivations. So what is the, how do we organize effort and what will be the goal for today? Today will be our last meeting on the skills of MATLAB. Starting from the next lab, we will try to apply them to realistic problems. If I remember my own plans well, probably we will try to duplicate whatever you do as a pen and paper homework too with MATLAB and see how easier it is compared to derivations. For the, and this Friday, I think we'll go for regular lectures to avoid excessive stress, but next Friday would be great if we fill sign-up forms and do another presentations on the MATLAB skills that we learned here, and they will be credited towards your final grade. Because presentations, I think it's not very hard to load, and if you chop all material by 4-minute segments, I hope you did enjoy it in the past and you enjoy it in the future. So, yeah, probably I'll start sharing. So here are subjects that we have covered in previous 2 meetings, and those in red are the ones that we are going to cover today. So by now, I want to believe, not just want, I have confidence that you are proficient in multiplying matrices, inverting them, finding eigenvalues, and using MATLAB for integration, differentiation, and plotting functions, right? Both real and complex. And sometimes sequence of operations that we are typing in command line needs to be repeated again and again for slightly different parameters. So basically, if one sets several standardized operations in one file and they are recurrently running, it's basically a program or a script, right? So today we are going to get our hands wet with very minimalistic scripting to the level that later on we can use pre-made scripts, modify them, and use them to our benefits. And the plan includes to cover saving and reading data. So last time we were doing like matrices and functions, and they were only in the random access memory of the computer. But if we find something useful, and it's completely normal for human to be lazy to make a screenshot with a cell phone or write down by pen and paper. If one can, so one can save anything we do, and we should just practice it a little bit. So one can save data that you computed onto the file, read them back if you want to restart tomorrow. And there is an option, there is an opportunity to read the data generated in MATLAB into your preferred software like Excel or Origin if you are doing scientific graphs with Origin. So those are regular data files. So it will be one section. Another, what should we do with cycles? So with scripts. So if someone gave us a script, we should be able to load, save, and run, right? Even if you do not know how it works. And then there are basically two things that we were missing in our previous meetings. So before we were considering that all mathematical operations are going in a streamline one after another, and sometimes one needs to make decisions to change mind which protocol to use depending on numerical value. So and please give me a sign if anyone is exposed to some scripting or computer programming. 1, 2, 3. Not exposed, doesn't care or not. Okay. Completely not exposed, or did you run any scripts? Oh, okay, good, thank you. So there are constructions for forking, and there are constructions to repeat the same procedure several times, cycles. And basically, if you add all mathematical operations, reading files, and this just two things, forking, if, and cycles, then basically you at this point you become programmers. You can demand, if anyone demands you to write a script, you can demand money back because it is expected to be a highly paid job. And the third section, which, like, if I would be in the class and I need to make presentation in a week and a half on a Friday, I would select the last one, how to make movies of based on MATLAB calculations. So it will integrate everything we learned before. And actually, when all things are there, just to present and run it, it's like 3 seconds. But if you need to do it from scratch, it's a little, how to say, challenging. So we'll need just to get the logic behind it. So I'm going to follow these lines, and I will make pauses and invite everyone to practice same exercises and make circles, visiting, and then we'll go further. Any questions, suggestions, objections? Objections 1, objections 2, objections 3. By silence, everything is accepted. Did you log into MATLAB on your devices? Okay, yeah, thank you. Okay, so if I do think that we were doing before, just start from the basics, like a vector, then I can do, well, maybe I'll say, so X and Y, and then I do, I'll combine both strings into the matrix with 2 columns. So I just created like a little array where first column is x and second is y, where y is x squared. Just a reasonable example. And I do want to practice saving and reading. So what if I do? Hey Nate, how are you? So the syntax is as follows. So this command does save the variable z into file z, and ASCII means it is in text format. Like command, first argument, second argument, third argument. I do not trust my memory, and I always forget which one, second or third, is a name of array and which one is name of the file. And I'm just calling them the same, giving them the same name to avoid this ambiguity. But your brains are brighter, you probably can figure it out and memorize. And in order to check what I'm doing, there is always an opportunity to check for the help, help, save, and it will give excessive amount of information that probably I never need in practical life. So you see, it's too much. I would probably avoid reading it, but the one who will vote to report to make a presentation on this subject is very welcome to glance through, just in case if some additional opportunities are available. Okay. So I noticed that several of you lifted your thumbs on the question, who has an experience of programming. Then I have even more tricky question, who has experience in running Linux operating system? Linux, Unix or Linux? One, no. Josh? Oh, okay. I see you have a Mac, right? And Mac OS is at the same time, it is one of the brand of the Linux. So if you have Mac OS, you can bring up the terminal application, and then you can talk to your CPU like with your friend in a chat. So, but if only few of you did it, so we do not need for this class, but for users, common users, we do have very comfortable like touch screens, mouses, and graphical GUI, graphical user interface. But for high productivity professional interaction with computers, it is a little more old-fashioned. So everything is typed as commands, and even to explore what CPU is doing, one just types commands like, "Hey buddy, CPU, what are you doing?" Well, not literally this way, but similar. And in this logic, one can type command list, which means like, which files do I have in this directory? And now, remember, my previous command was the save minus ASCII ZZ. Then I do ls, and you see there is a variable z. So you may use your computer environment to locate this directory and open this file using your computers. And if you want to locate which directory it is at, first you can type pwd, and it will show where it is located. If you right now I'm using on the remote server, but in on your Windows PCs, it will show something like C/user programs, like documents, and then this stuff. Approximately, if you are on the Mac, it will show something like user, then your name, and then documents, something like this. And then you can try to open it just by double clicking, so to see this data. So please try doing it. I'll try to, no. Let me just walk around, and if everyone will have difficulties, then I do another demonstration. But if you find it easier, then I will just, let's do it quick way, because in the environment I'm using, it will be longer. Maybe you will be extra quick. So the little exercise that we are trying is just to create 2 column files, save it, and then try to open it on your favorite environment.
Since I wasn't here, I didn't see it.
Okay, let me type something right away. Then we go to File Explorer and try to find users need documents MATLAB. Can you? And I'll make another stop. Okay, can you open file browser and try to navigate to this directory? Open it with Notepad. Okay. You did right, just do not.
Oh.
No, let's go once again. Browser, file browser. Go to this directory and open with Notepad. Like select application. So you see same numbers.
Mm-hmm.
Notepad would be good. So do you recognize that numbers are the same?
Yeah.
Okay. Okay, let's open file browser. Not in MATLAB, just for in your operating system. This little stuff. And then navigate to the directory where you do this exercise. Let's look once again at the so users JJCI OneDrive. So it's OneDrive. Okay. Good. And then what is after OneDrive? Documents MATLAB. Okay. So where is your documents? Let's go to documents folder. I think the
This one says as a Word document.
no documents as a folder.
Yes.
MATLAB. Then go. And now try to open it with Notepad. It will ask me which software. Notepad. It's second from the top. Do you recognize the numbers? So like 0, 1, 2, 3, 4, 5, and then 0, 1, 4, 9, 16, 25.
Yeah.
Okay, yeah, excellent. Thank you. Were you able to open it in Notepad. What's going on? Okay, so it would be great if you can go into this directory and open the file named Z, and you can use your file browser. Just do whatever you find reasonable. And open file Z with Notepad. Select application. Do you recognize the numbers? Okay, so you can access whatever is generated by MATLAB in other applications, right? Perfect, thank you. Excellent, yeah, thank you, Alison. Yeah, thank you. Okay, so we can save data from MATLAB to local computer. I'll probably skip it, but the one who will present it may try to open the file not with Notepad, but export this or import this data into Excel or into Origin. And then I am a big fan of MATLAB. I hate Excel, but some people are addicted and attached to Excel, or some people who like MATLAB is for free here on campus. Origin is not. It's expensive, but some people prefer graphics made by Origin. So if you prefer other software, you can generate data with MATLAB and then make pictures with other software. And the one who will select the subject may develop a little illustration how to plot these lines with other software. Now, I'm typing who. It means it tells which variables are saved in the random access memory of this computer, of this application right now. So you see this X, Y, Z, and something else. Now, suppose I close and reopen, and it will be wiped off. Or I can just type clear. Now I type who, and it shows nothing, no one. So I did erased all data. And suddenly I remember, oh, no, it was so important y as an x square function that I cannot reproduce other than reading the file. So now I need to read this data back into MATLAB. So I can type uz or whatever equals load z, comma. Let me check. Oh, yeah, it works. So I typed just new z load file z. And then if I type this new z, it has the same information, right? So I can load and read data with the file. And it is when we will do something a little more complicated than like 2x2 multiplication, we may need to save intermediate data, especially if you are working on some little problem longer than one session. You save whatever you did, and then you let your computer sleep, you sleep yourself, but then you can read everything back into the random access memory. Let me make a little tour and check if this reading exercise works. Yeah, thank you. Okay, excellent. Yeah, thank you. just close the bracket, new Z, close the bracket. Enter. Let's type PWD. Let's type who, and let's type ls. So you have variable Z, arrow up, yeah. Arrow once again, no. This word Z, and then let's put apostrophe before, not comma, apostrophe before and after the code. Enter. Okay, it works. So the convention is that apostrophes means it will be not a name of variable, but some text. And the file name can be something more advanced, like my best file or most important data. And okay, so we are done with this stuff, right? And one more trick: if you type save without any argument, it will save all variables that you have by now in the file called like MATLAB data. If you start new session in the same directory and you type load, it will load all variables back. So it like same as on some computers, all windows on your desktop are popping up back after you reboot. Okay, so going to next thing, load, save, run if cycles. We'll do it next. So in your MATLAB window, there is a button like editor, new, and you click, you can click on the new script. And then in the script, you can repeat same commands as we were before doing in the command line. So I just do not have any fantasy. I can type like x equals from 0 with step 0.1 to 10. Plot x comma sin x, and then so it is ridiculously simple and short. We just need a basic concept of doing it, and then I do save as, and I can give it a name like my first code or anything I like. So saving it, and then if I inspect the command line, if I type ls, you see in addition to variable z, it has this my code, right? And I can type my code without .m. .m means it is MATLAB script. I click, and then something should happen. And then a figure pops up and does whatever I ask it for. Let's close it and try once again. So my code, and things pop up. I prefer very much to type the name of the codes in the command line and recommend to do it, but there is a way that majority of class attendees liked in previous years. So instead of remembering what is the name of the code and where it is located, there is a like play button, same as MP4 or MP3 players. Just click and it runs. Okay, let me do a little visit and make sure that everyone feels happy about it. Okay. Yeah. So a little comment to everyone. Most computers, except very, very recent, like that were operating systems that were developed in the last like 10 or 20 years, which is very new. Everything was more classical, what was made before. All computers and operating systems really hate empty spaces in the file names. So if you are creating a file name, I know that today operating systems tolerate it, and you can create Microsoft Word file called my space course space work. Not every computer will tolerate it. It's better if you really want multiple words, do my underscore symbol thesis or whatever. So empty spaces considered as a separations between different names. Okay, yeah, thank you. Yeah, perfect, thank you. That's great. Michael.m. Okay, and then save it once again. And you did, you click save. And let's run it once again. Okay. Yep, thank you. So it is kind of oversimplified thing, but anything we did before can be written in the set of lines and repeated. What can we do?
Make that one a little bit bigger.
Yes, I will.
We're just missing one.
Yes, yes. I want to check that I didn't make any mistakes. And I don't want to instruct you wrong thing. Okay, so it will be not the best example, but if I would prepare, I'll probably do something more spectacular. So here is just an example of condition. So I set some trigger number, and then I'm doing one operation, but then if the trigger number is equal to specific, if some condition holds, then I do another operation. Makes sense, more or less? And now, if the trigger number is not the key value, it should plot cosine. Let's try it. So you recognize it as a cosine function, right? Now I change this trigger value to something different, saving, running once again, and you see it is another function. It is sine. Make sense? So let's try this example and check that you and MATLAB will like each other about the syntaxes. So one should put like two equal signs. And if you are in doubts about this, or if it will be your turn to present this stuff, one can do help if, and it will again provide an abundance of details and syntaxes how to use them. Okay. I'm going to make visits unless you request me to give more details. Is it enough? Okay, can you change the number? Save. And bring up the, yeah, excellent, thank you. Okay, and if you change the trigger, yeah, thank you. Okay, thank you. Okay, and if you change the trigger in the script. And save. And now in the command line. Okay, excellent, thank you. And can you demonstrate how it changes? Okay, thank you. Okay. You can just run. Yeah, so thank you. Okay, and if you change this trigger number. Oh, you also have Mac, so you can bring the window with graphics, or if you cannot find it, just here. Or can I touch it?
Yeah.
disappear, you can open your figure. And then
Oh,
okay, and oh, here you can
there.
bring it up. Okay, yeah, everything is great. Where's your applications button for?
Like the finder,
Yes.
this one.
Okay. It's something like, yeah, utilities. It's not for the course, I'm just demonstrating opportunities. So you're asking CPU what it is doing. It's like task manager and then stop it. And there are many other things. So your map automatically has Linux.
Okay.
Well, maybe you never need it, but just in case. Okay, so we are done up to here, and now we need cycles. So when sometimes we need to repeat sequence of the similar procedure again and again for like iteratively changing parameter. And I'm just not very fresh today, but my favorite example, which we will use again and again in this course, is with time propagation. For example, with evolution operator. And maybe it's too complicated. One can find much better, much simpler examples. But if we do have past, and then we have evolution operator that acts for very short time, then we predict near future just by propagating forward in time, and then we rename our near future becomes our past. Then we apply another evolution operator and we get next near future. And then we can repeat this procedure again and again and again, and then we scan through all time instants and go from continuously from past to the future. This logic will be used in the main code that we will use in the middle of semester and for the projects. But one can design some other situations when cycles are needed. For maybe I can find something better. Basically, a lot of things where cycles are needed are already encoded in, for example, such operation as summation that we used for integrals. But if I do not have this sum command, for example, I need to solve a very silly problem. So it will be a made up problem, not for like actual science or computation. And then I'll probably tell you a joke about this problem. So suppose I need to add numbers. From initial to final, just natural numbers. Suppose I do not have a command sum and I cannot set up arrays. I want to basically design the sum command myself. So I would design a command that takes a variable and continue sequentially assigns it values from the sequence, right? And then at each step, I will call my some result, whatever was before plus current value of this thing. So I will take this, then this, then this. So I will like add more and more pennies into my pocket, right? So this can be done as for I equals from 1 to 10. Then this sum equals sum plus I, then end. And then I can just type sum without a semicolon, and it will give result. So as a good practice, I can count until 9. It will be easier for me, a little easier. So can we say what will be the result of adding together all numbers from 1 to 9? One, 2, 3, 4, 45, right? So the result should be 45. Now let's do this exercise and make sure that it works, and then I'll tell like a little historical joke. So going back to here, creating new script and tell I equals from 1 to 9, sum equals sum plus I. And here I need to 4 to have a cycle. And then I need end at the end. And then I want to output the result. Save as. My rustic and artificial sum. And now let's check if it works. My sum. Okay, 45. So it agrees with what we predicted, right? So please practice and make sure you feel comfortable with it, and I'll make visits. Remove the semicolon here so that it will output the answer. Let's do from 1 to 9 instead of it's some advanced recursion. Okay, save and run. Yeah, excellent. Thank you. Okay. Perfect.
Yep.
Great. Thank you. It should be lowercase if it is lowercase, like either uppercase or lowercase everywhere. And
Something else.
maybe interesting. And at the end, make at the line 5 add SM without semicolon, just type SM and nothing else. Okay, and now save and run. But the answer, so put semicolon here after SM plus I. Your answer, yes, semicolon. Okay, save and run. Great. Yeah. Yes. because we need to set clear space, like prepare this unit of memory to accumulate data here, just in case if it was used for something else. Yeah. Yeah, that's great. Thank you. So now a little historical joke that I promised. You saw the picture of Gauss this morning, right? So there are there are stories about him being a kid in the middle school. His math teacher was not dedicated to the profession and just wanted to get rid of the kids during the lesson and read newspapers. And he told like, okay, guys, we do have an assignment for today's class. Take numbers from 1, 1, 2, 3, up to 100, add them together and report me the answer. And he was counting that everyone in the class will be busy with this task for like 50 minutes of the class, and he will have time to do his things. And 5 seconds later, the young Gauss told like, I do have an answer. So let's, in some sense, this little program is not as needed. So can you give the answer in 5 seconds? Let's try doing it together. Yes, so here is the hair of Gauss. Can you explain to everyone how you use it?
I just replaced 9.
Okay, then you are hair of MATLAB. So let's look here. What will be 1 plus 100? What will be 2 plus 99? How many such pairs do we have? Right? So it was a shame for the school teacher of Gauss. And it is called arithmetic progression. You take first and last terms of the series, divide by 2 and multiply by number of terms, right? So first, last, divide by 2 and multiply by last. Okay, so we are done with this stuff as well. Now, oh yeah, we are doing fine with time. I need to take a breath. It's my most pleasant part, but I need to be brave to show it. So maybe let's do just a little other exercise and without new information, just practicing, do more practice, and then we'll go to the images. So in the email, I did send a couple of example scripts, and one of them was the code, right? So if you either open it in MATLAB or just copy paste it into the script, we can run it and see that it will be just another visual stuff. that we can practice. So what I'm showing right now, it doesn't bring us anywhere. It's just another example, so that basically for myself that I can take a breath and prepare for next important step. So here I'm trying to just enjoy three-dimensional pictures of product of sine and cosine and see how it will look like. So it should be like mountains, valleys, and ridges, right? And in order to plot such things, there are either mesh or waterfall commands. So I'm going to, yeah, just type my code. No. Oh, no, it's not this one. It's the script. The script. Yes. So along one dimension, it is sine, along another, it is cosine, and it shows this oscillating patterns. Why is there any benefit in plotting this figure? No, it's just a little exercise, but if you want really to make any benefit out of it, it's when we were discussing the definition of standing waves. So it's certain nodes and minima or maxima along one dimension, and then oscillation around another one. So we may need images like this in the future. So I will not make a visit, just try to play with it, and I'll prepare some materials to introduce you to making videos. It will be not long, but I need like maybe 2 or 3 minutes to prepare. Mhm. Okay, I think I'm ready. So first, let me explain what I'm doing. The we can think of illustrating the standing wave, right? Where the nodal points will be the same, but the elongation will be changed from minus amplitude to plus amplitude continuously, right? So if we do not like three-dimensional pictures and we want to see it in motion, like one-dimensional wave as propagating in time, we need several snapshots, several slices of this image. And the basic idea behind movies, it's just frames per second, right? Frames are coming quicker one after another, and our eye considers it as a continuous motion. So we may want to set up the spatial part, then temporal part. So here's time, which will be changing. I request like 200 frames, and it will be changing from 0 to 4 pi. So it will be like 2 full cycles. And each time we come through the cycle, it will be slightly different phase. And each time I plot it. And if I do not specify axis, it will automatically update the axis so that it will be a little messy for human eye. So I just specify that these stay fixed. Now, how do I, what is my goal? I want to combine these frames into one file, into one video file that I can later upload to YouTube and enjoy and share with friends. So there are 3 commands that I need to add to this script in order to save it as a video file. And you can see them in the email that I've sent to you. So first, well, everything happens inside the loop of frames. Before loops, Well, one needs to activate file where one would save it and assign it to like variable and open this variable. And if I forget about it, I will look in the command line like help video writer, and it will instruct me on this instructions with abundant details that I don't care of. So opening the channel to save frames. Then inside the loop, I use this keyword get frame, which basically captures what is on the script in a given time. And then it pushes the current frame into this video object, into this variable. Just in case inside the cycle I can do pause so that they do not go too quickly. And then after the end of the loop, I need to close this stream to stop recording, and the file will be ready to the use. So I did practice this protocol here. I'll try to open the whole thing. So I coded like test. And then there is a loop. Let me make less empty lines. So inside the loop, I make this function that will be changing depending on the variable loop plotted, and then capture the frame into this object. And after the end of the loop, I close this video object. So when I run the script, first we will see on the screen that it will be this oscillations of the standing wave. And second, if I look into the files, it will show that the file has been created in the directory. So what I'm going to do, first I will copy the script as a text and send to everyone as an email. So that if you want, you can skip, save time on typing. Then I will ask you to like create it as a script, run, make sure it works. And then after you identify that it works, we will try to take this file, this movie file that you have created, and upload it to YouTube. So the program maximum what we can plan for today is that everyone creates a YouTube video and sends a link to me. And I will assist in doing it. But first, let's make the first part and do the script, run it, and make sure the file is on your computer. So I'll make 2 visits to each of you. Okay, yeah, that's great. Excellent. Okay, yeah, excellent. It complains to you? Let's see. Bring a chair and try to do some little inspection. And okay, so it ended successfully. And test for us. So you have this file. Can you open it in your file browser? Yeah, it works. Excellent. Thank you. Okay. And can you type ls in the command line? Type ls. Enter. So you have Siren J016 MPs AVI. Yeah, yeah. Can you open this file in file browser? Just yellow thing. Yeah, this one. Excellent. And you can just, okay. Can you open the resulting file in file browser, the video file? Oh, it is waiting until this one. It saves. I was too quick to ask it. Let's close it. Perfect. Yeah, thank you. That's great. Can you open this file in your file browser? Let's close this window. Close this window. Yeah. Now type ls in the command line. So you do have the test mp4.avi, right? Can you find it in the file browser and open? Perfect. Okay, and can you open this test.mp3 in your, in Mac instead of, it's Finder, right?
Yep.
Can you locate this file and yeah, this test. No.
Test one.
Yeah, this one. Okay, maybe there are some missing codecs, but do not worry. There is a way to open it either another way. I'll show it.
Okay.
So let's do the thing that will be a little complicated for me to demonstrate on this central station, but will be very easy for each of you to do on local stations. So do you please show if you have Gmail accounts in addition to NDSU? Yes or no? Everyone has. Now in browser, please log into your Google account so that you type in your credentials. And in the side window, just open a YouTube. Now, I will not show the full cycle on the station, but I'll just demonstrate. So I'm logged into my Google account. Then I type YouTube. And there is a button plus for create content. So please click on this button, upload video, and then it will give you option to select files. So in this select files window, please browse and find your video made by MATLAB. Even if you were not able to play it on your computer, just find this video and follow steps after that. And steps will be just clicking OK, telling it's not for kids and giving it's a name. It just wants to make separate accounts for entertaining production for kids and something for other group of people. Okay, so yeah, you can cut, and after upload and conversion is done, please copy paste the link and send it as an email to me so that I can check how successfully and probably add likes to you. Or you can send it to the whole class and then we all add likes to each other and each of us will have like 9 likes. Unfortunately, we are not in 200 attendees. Otherwise, we'll fly like a rocket. The video file, yes, this one. And if you want, you can write description that is the video created under instruction of the best teacher. Or it's NDSU, physical chemistry, but that doesn't matter. Example. Enough. If you scroll, it will ask if it is made for kids or not. No, it's not made for kids. Next. 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 And then I think you're okay to make it public, right? So click public. Click next, publish, right? 2 seconds video. And then copy the stuff and email it maybe to the whole class. we will rush to add likes to you.
Problem is, I'm not gonna, and it's with this computer, so I need, so maybe if I can send you do work on it like after I get back to my room, then so I can connect it to the Ethernet.
Oh, okay, yeah, let's check, maybe we can solve this. Let me check if you can solve this problem, which, do you have USB,
I don't.
USB A and USB C?
Yeah.
Let's try to fix it right away so that you do not waste time. Let's try if you can plug this one in. Okay, and then we can unplug Ethernet here. Just do not forget to put it back in after we are done. Yeah, check. It should work. Are you done? Did you?
Yeah.
I wasn't checking emails yet. Are you done? Okay. Okay. Yeah, thank you. Let me check the emails and start putting likes to the videos if anything arrived. Okay, 3 messages. So the first was Lola. Open link in new tab. Like. Can I? Oh, subscribe. Sure, subscribe. Add public comment. Best video. Cool. Okay, who is next? Wyatt. Open link in new tab. Oh, someone. I'm not the first who put a like play again. Okay. Subscribe. Yes, of course. I want to play it again and again. Okay. Next one. Sibel. Open wiki in YouTube. 2 likes. Okay, you learned the system. Subscribe. Yes, sure. It is a truly fun video that teaches me a lot. Okay. What's next? No? Oh, Joe. Let's open in new tab. Unlisted. So you do not want the rest of the world to find your video. What can I say? Humbleness is a merit. Keep it unlisted. And of course, subscribe. Yes. Okay. Anyone else? No?
Yeah, I think our other ones are under.
Or you send it to my other account?
I probably said, yeah, to your other one.
I do not remember password, it's better send it to my, I use this account only to class activities so that it doesn't interfere with other things. But if I do not find it right now, I'll do it when I come home. So I promise to leave some likes and comments to each of you. So any questions about today's activity? Everything is crystal clear. Anyone wants more comments from me? Okay, then we are done, right? And I think we are done earlier than planned. So many thanks for your dedication to the class. Meeting is done. Everyone is welcome to disconnect and depart. I'll just stay here a little bit to answer questions if any, but I'm going to stop recording and share it, although everyone learned everything. Probably you are doing fine even without watching this recording.